So in this video, uh, we'll try to look at same solving quadratic equation by using completing square method. So if you haven't watched before, watch the one where I've taken the simple one. Here I've taken a little bit of difficult, if you think so. So let's try the difference between the quadratic equation what I had taken before and now is little bit complicated, and as well as the one thing you might have already noticed that I have a coefficient for my x square. So last time we actually went through the identities a plus b whole square and a minus b whole square, what needs to be there and what we need to look in that particular equation. So first, if I am going to take x square, I can actually take this as 2x whole square. 2x whole square. 2x whole square. Then what happens is a will be 2x. A will be 2x. But what we'll do is, in not all the situations you will have the same kind of question. So sometimes if it is 3x square, I won't be able to write it that way. I can actually take it as root 3x whole square. If you can manage with root 3, yes, you can actually change this. But then again, the problem is what you will have in the midterm of these particular identities, plus 2ab minus 2ab. So will you be able to manage that root 3 in this? So for to avoid all that all those confusions, what we'll do is we'll divide this entire equation by 4, which is the coefficient of my first term. So 4x square divided by 4 gets cancelled, so I'll be left with x square. Here also 4 gets cancelled, so I'll be left with a square x. And here, same in the last video we have done this. This is my c, which is the constant, so I'm going to move it onto the right hand side. So for that reason, what will happen is it will change the sign to minus a to the power 4 minus b to the power 4. But we should not forget that we are dividing the entire equation by 4, so this will be divided by 4. Looks complicated, but it's not. Let's try. So now I know that I can write this straight as x whole square, which is a square. Always keep in mind that whatever we introduce, we are not changing the equation by introducing something. Keep the same thing, but if you should not change and then try to use the identity. So here if you look at it, I need, because I can see minus, so that's actually going to be this identity, a square minus 2ab plus b square. Minus is there, that's what this is a minus, so that's what we will end up with. So now 2ab, there is no 2, I'm introducing 2, that means I have to divide by 2. 2 gets cancelled. Remember I said we should not change the value of the equation. 2a is there, whatever is left is this. So now let's go back to this again and see. 2a, whatever is left is b, which is 1 by 2 multiplied by a square, which is going to be a square divided by 2. That is actually going to be my b. So that means I need to add here the one more term plus b square, which is a square divided by 2 whole square. If I am adding the term here on the right hand side as well, I need to add, so that we didn't change anything in this entire equation. Minus a to the power 4 b to the power 4, let me put that bracket here, divided by 4 plus a square by 2 whole square. Now as you can see, if this get cancelled and then this 2 gets cancelled, our equation remains same. So I'm going to take that out, right? So now what we'll do is we know that this entire thing is actually going to give me a minus b whole square. A in this case is x, minus b is a square by 2 whole square, equals to, on the right hand side, minus a to the power 4, I'll open the bracket, let's see, b to the power 4 divided by 4, and a square is, no sorry, that's not equals to, that is plus, and a square is a to the power 4 and 2 square is 4. I'm squaring both numerator and denominator. If I take LCM, I'm going to do it this LCM here so we can get the x values on the left. So if I take LCM, that will be 4, which is same, and the numerator also going to be same. A to the power 4 plus b to the power 4 plus a to the power 4 plus a to the power 4 and minus a to the power. They get cancelled. So I'll be left with b to the power 4 divided by 4. If I take out this square, this will become square root. Then the value of that square root will be b to the power 4 is b square square, so which is actually going to be b square. Root 4 is 2, is going to be plus or minus. Square root of both of them, whatever comes out, and then put them as plus or minus because we need two values. And on the left hand side, I'll be left with x minus a square divided by 2. So you have to keep that in mind. So now if we transpose this particular term, what I'm going to get, x equals to, this will change the sign to a square plus a square by 2, and on the other side I have plus or minus b square divided by 2. So if I separate this, that's actually going to be, and if I take this okay, let's separate this one, that will be a square divided by 2 plus b square divided by 2, or x equals to a square divided by 2 minus b square divided by 2. From here it should be straightforward. If I take LCM, this will be a square plus b square. It's the same LCM, so in the denominator all we have to do is just add or subtract in the numerator. So these are the two solutions for this particular quadratic equation. So the challenges that you might face if it is of if you are going after with factorization method, you might end up little bit longer. During that time actually you need to find out exactly what are the splitting midterm. Our quadratic formula might be easy, but this video is focused on completing square method. I hope from the previous one and the current one you have understood exactly how to solve two different types of quadratic equations by using completing the square method.